8.3 part 2, we're just going to practice with the same rules that we were doing yesterday in part 1, but just do different examples. So with number 7, I think there's one that's, if it's not exactly the same as this, it's super similar to this in the homework. So for here, if you notice like the pattern that we've been following, we know that the derivative of the ln of x is 1 over x. So I'm going to let u equal the ln of x. So what would du equal? 1 over x. 1 over x dx. So I can substitute the 1 over x dx, the du into that, and then I'm going to substitute the u into the ln of x. So I have the integral of 1 over u du. Now what's the antiderivative of 1 over u? Awesome. ln of the absolute value of u plus c. So then the last step, we just want to plug in what u is equal to. So we're going to plug in the ln of x. We have the ln of the absolute value of the ln of x plus c. So that would be our answer. Remember, you can always check your work by taking the derivative of this. When you take the derivative, you should end up with your integral. For number 8, there's a couple different ways we can solve this. I'm going to show you there's a number 8 on this page and number 8 on page 2. So I'll show you 2 different ways of solving. But I'm going to let u equal our denominator. So the square root of x plus 1. So then du would equal the derivative of u. So what's the derivative of the square root of x? It'd be 1/2 times x to the negative 1/2 dx. Or I can write that a little bit differently. I could write it as 1 over 2 times the square root of x dx. So I'm going to substitute u into my denominator here. But I don't have a 1 over 2 square root of x dx, and I can't just plug in an x if I don't have one. So what I want to do is I want to find what dx is equal to, and then I can just substitute what dx is equal to into dx and use our substitution that way. So I'm going to use my equation here that has the dx in it, and we're going to solve for dx. So we're solving this one here for dx. That way we can just use substitution and substitute into the dx. What would I do to solve here? From solving for dx, what should we do?
Set it equal to du.
Well, we want to move everything to the other side.
Yeah.
So how do we do that?
Multiply by 2 square root x.
Yes, we're going to multiply by 2 square root x on both sides. So we get 2 square root x du is equal to dx. Now I'm going to take this and substitute it into my dx. So we have the integral of 1 over u, and then dx is 2 times the square root of x du. Now we can't take our integral if we have u's and if we have x's. So let's replace our x with a u. I want to now find what the square root of x is equal to in terms of u. So what do you think I would do here? Awesome. We're going to solve this equation that we have for the square root of x. So I'm going to subtract 1 on both sides. So u minus 1 is equal to the square root of x. So now I'm going to substitute u minus 1 into the square root of x. So we have the integral of 1 over u times 2 times u minus 1 du. Any questions on what we just did? All right, since 2 is just a coefficient, I'm going to pull it out front. So 2 times the integral of u minus 1 over u du. So I just multiplied everything together and pulled the 2 out front. What could we do to take the antiderivative here? Bless you. Awesome. We want to separate the fraction. So I've got 2 times the integral of u over u minus 1 over u du. Now we can split up our integral and integrate each one of these separately. So anytime you just have one term on the bottom and you've got multiple things up top, when you're taking the antiderivative, when you're integrating it, you probably are going to want to split it up. That's why we use u substitution, is to kind of get that solo u on the bottom, so then we can split it up and it makes taking our integral easier. So I'm going to break this apart into 2 times the integral of u over u would just be 1 minus 2 times the integral of 1 over u, and both of these have a du. So here we have 2. What is the antiderivative of 1 du? It's not x, but it's, what letter are we doing here? U would be u. So 2u minus 2 times, what's the antiderivative of 1 over u du? ln of the absolute value of u plus c. Last step we want to do is plug in our x's. So I know that u is equal to square root of x plus 1. So we've got 2 times the square root of x plus 1 minus 2 ln of square root of x plus 1, the absolute value of that. We could just simplify this a little bit more, distribute the 2, so 2 times the square root of x plus 2 minus 2 times the ln of the absolute value of x plus 1 plus c. Now, I'm not sure if this was a WebAssign question, if WebAssign would take this, but because 2 is a constant and c is a constant, we can combine these together. Because c is just some constant c, so if we add 2 to that, it would still be just some constant c. So this would be 2 times the square root of x minus 2 ln of the absolute value of the square root of x plus 1 plus c. So we can just combine the 2 and the plus c together. So this would be our answer. For number 9, we have the integral of an exponential function. So our rule, this was rule number 4 from yesterday. It is the integral of a to the power of x is equal to 1 over ln of a times a to the power of x plus c. So what would our integral of 3 to the power of x be?
Over ln 3 times 3 to the power of x.
Awesome. 1 over ln of 3 times 3 to the power of x plus c. All right, so the next one is number 8 again. I told you I'll show you a different way of doing it. I wouldn't really say one way is less steps than the other, but it's just kind of 2 different ways of thinking about it. Here, I'm going to let u equal the square root of x. So I know that du, I'm still not going to have what I need exactly to just substitute right in. So I want to figure out what dx is so I can substitute into dx. So to do that, I want to solve my equation that I have right now for x. So I have u equals square root of x. Let's solve for x and then we'll differentiate that. How would I solve u equals square root of x for x, just to get x equals? What would we do? Square both sides. So u squared is equal to x. So now if I take the derivative of this, what's the derivative of u to the second power? 2u du is equal to the derivative of x would be dx. So now I'm going to substitute in what I have. So the integral of 1 over, I'm going to substitute u into the square root of x, so u plus 1. And then I'm going to substitute 2u du into the dx. So I'm going to pull out the 2 as my coefficient and just multiply this together. So 2 times the integral of u over u plus 1 du. Now from here, what did we say yesterday that we should do when our degree of the numerator and the denominator is equal? Divide. We want to divide. So I'm going to divide. What's up top is going to go on the inside. So u divided by u plus 1. So we want to think, how many times does u go into u? 1 time. I'm going to put a plus 0 here just to act as a placeholder, but it goes in once. And then we're going to multiply, so we get u plus 1. Change the signs and combine, so the u's cancel, and we're left with negative 1. Can I divide negative 1 by u? No. So this would be our remainder. So we want to write our remainder as a fraction, so I'm going to say minus 1 over u plus 1. So 2 times the integral of 1 minus 1 over u plus 1 du. What should I do next? Let's separate it. So we have 2 times the integral of 1 du minus 2 times the integral of 1 over u plus 1 du. So when I separate it, since I have that 2 outside of my integral, when I split it up, it's going to go outside of both parts of my integral. If you wanted to, you can leave the 2 outside of brackets, put brackets here, and then split it up and just multiply 2 at the end. You could do that too. Just don't forget about the 2. It goes to each integral. So what is the integral of 1 du? U, awesome. So we have 2u minus 2 times, what's the integral of 1 over u plus 1? Awesome. The ln of the absolute value of u plus 1. Perfect. Plus c. And then what's our last step? Plug back in the x's into the u's. So u is equal to the square root of x here. So just the square root of x is getting plugged in. So we have 2 times the square root of x minus 2 times the ln of the absolute value of the square root of x plus 1 plus c. So the difference in both ways for number 8 is when we started the first time we did it, we made the whole denominator u, which worked out. We ended up with the same answer, so it worked both ways. This time we only made u the square root of x, and then we manipulated and plugged in that way. So either way works. These questions are different because it still involves the old strategies of integration plus the new strategies. So just make sure you are practicing the homework.